All right, now we're going to talk about the electrolyzer, which is a device that uses electricity to split water into oxygen and hydrogen. These are the parts of it. This is an example of assembly. You want to present it on the shelf like this, whether it's on a tray or in a basket. That's up to the individual teacher. Here's what the child has to assemble. The handle is made. Simple acrylic plastic, rubber grommets that will stabilize the metal rods, and the copper contacts already bent and in place and shaped into springs. So we have a copper rod. Go into the top, wiggle it down through, twist it a little bit. As far as the child is concerned, this is basically a peg in a hole exercise. Aluminum. And through the other side. Turn it while you push. Go a little farther with both of these. And there it is, the assembled electrolyzer. Now we have to put the battery in. Here's a control of error. The copper has to be connected to the negative side of the battery, otherwise the reaction halts and the copper rod immediately corrodes and you need to clean it. Now you get to sort of play with these, spread them apart. In comes a glass of water, just basic water. And you set the electrolyzer on top. It sits on the top of the cup. Make sure they're not touching. That's the important part. All right. Now we're going to zoom in a little bit. And you will see bubbles start to form on the rods. Takes a little bit. This can be considered a stillness exercise because you have to wait for it to happen. But here it's starting. You can see them on the rods. You can see a little bit of motion in the water. Let's go a little closer if we can. All right. So for us, this is electrolysis. For the child, it's making bubbles by passing electricity through water between two metal rods. The bubbles are, on close inspection, two different sizes. You got a little one and a big one. The little one is hydrogen. The big one is oxygen. Turn the camera just a little. There we go. So what you're looking at right here is a dynamic process, which, given the water and the salt we're about to use, could qualify as a practical life exercise as well as an electrical or scientific exercise. And so what I'm going to do now is add some salt, because salt increases the conductivity of the water. Let's see if I can show you a little salt in a spoon here. The preparation of the salt is itself a practical life exercise, because you're going to use a salt grinder to make it nice and fine so it will mix easily when you spill it into the water. Here we go. Salt in the water. You can see that fall through the water, and in a minute you'll see the reaction begin to accelerate as the salt mixes. See it rising through the water. The bubbles are starting to be a little more visible as they boil off the electrodes. Yeah, we got some nice action going there. So one thing that's happening here is the child is now looking at four elements of the periodic table. We have copper, aluminum, hydrogen, and oxygen. You could relate that to a periodic table if you have a picture of it on the wall. So the rest of the process is that you observe this. The child observes it until she's happy and she's had enough. Then you have to disassemble this. You have to take it apart, dry the rods off, return the piece to the shelf, and then put the water wherever it is you want to put it in your classroom. I wouldn't suggest a fish tank. It does have salt in it, but an outdoor plant garden probably would be just fine. Otherwise, you could just move it over to some other pouring exercise. But there you have it. Electricity, water, the separation of water into oxygen and hydrogen, and really it's a combination of a peg in a hole and a pouring exercise. Kind of cool. At least I think it's kind of cool.